Welcome to Hydraulic Power for the Airbus A350. This is Session 1. Session 1 is on the consumers of the hydraulic systems, and we're going to talk a little bit about what hydraulic systems do we have on the Airbus A350. For starting out, we have two main hydraulic systems. I will later talk about an auxiliary hydraulic power system, but for now, as far as the main ones, there are two of them. They are labeled the green and the yellow hydraulic systems. If you recall from A320 Airbus family, there were three. There was also a blue hydraulic system, and here with the A350 we do not have a blue system per se. So these two hydraulic systems, what are they doing? Okay, besides we know that they're operating independently, right, because you want to have redundant systems and have the ability to still run the aircraft if one of them goes down. So they do run independently. There's not an exchange of hydraulic fluid or sharing of hydraulic fluid between the two. They are actually completely separate. The green system, let's start with what is the green hydraulic system supplying power to? What are the consumers? Those are going to be different. I'm not going to name them all, but just so you have an idea. The flat power control unit. You also have it's controlling the main landing gear pitch trimmer for both sides, left and right. Also the left and right spoilers, your 3, 4, and 6. And so you have those, and then also your EHA of the right hand inboard actuator, your rudder middle actuator and left elevator. It's also supplying the RAM, your ram air turbine, as well as the main landing gear extension retraction system with a priority valve. Okay, so that's your green hydraulic system. It's also in charge of some other components, but I just wanted to give you an idea, especially when we talk about the main landing gear, because when we're comparing what the yellow hydraulic system does or does not supply power to, then you can really see the distinction. And in particular, the main landing gear is powered by the green hydraulic system. Now, when we talk about the yellow hydraulic system, the yellow hydraulic system is supplying power to the rudder upper actuator, as well as the left and right hand inboard ailerons, your slat and flap PCU, your EHA of the left inboard aileron, your left and right spoilers 1, 2, and 7. Okay, so remember your green hydraulic was in charge of supplying power to the left and right spoilers 3, 4, and 6. The yellow hydraulic system, on the other hand, is supplying power to the left and right spoilers 1, 2, and 7. In addition to that, the yellow hydraulic system supplies power to the nose landing gear extension retraction system and also the right elevator. So remember I said about main landing gear extension retraction system, that is actually being run by which? The green hydraulic system, right? And as far as your nose landing gear extension and retraction system, that's being run by the yellow. So I just wanted to give you an idea on the users of the hydraulic power. And certainly we also have fuses, because we want to protect the hydraulic systems from any adversity that could affect the supply of hydraulic power to those users, and that's why we have the installation of hydraulic fuses. The hydraulic fuses are installed on the lines. They actually are going to close the lines if there's a detection of a significant enough of a leak. Because you could have little leaks here and there, but at some point, if it's going at a certain rate of leakage, then the hydraulic fuses will actually close those lines. All right, and do pay attention to the video, because there are the questions that are peppered in between, and some of the you may be a little bit surprised to see that some of them might be at the end of a session or maybe at the end of an entire topic. But it's just so that you're, want to make sure that you're paying attention along the way. But those questions are listed here, so do visually see what they are. The answers are on those slides. We are continuing on with questions for the Airbus A350 on hydraulic power. Follow along in your handout. We are now on question number 4. Where are the fire shutoff valves installed? Is it in the return lines from the engine-driven pumps to the reservoirs, or in the suction lines from the reservoirs to the engine-driven pumps? Okay, the answer is the B. Then the suction lines from the reservoirs to the engine-driven pumps. All right, number 5, the A350 has a rudder isolation valve that isolates the rudder actuators. Is that true or false? That's true. Number 6, what is the function of the priority valve? Is it A, a valve that ensures the flight controls get hydraulic power only if sufficient pressure is present? Or is it B, a valve that ensures that the main landing gear extension retraction system gets hydraulic power only if there is sufficient power available? Okay, the answer is option B. All right, number 7, the Airbus A350 has an auxiliary hydraulic system which serves the same function as the blue hydraulic system in the A320. Is that true or false? The answer is true. Number 8, to manually close the fire shutoff valve, you can push the ENG fire push button. Is that true or false? That's true. Number 9, to manually close the fire shutoff valve, you can push the supply OVHT ISOL push button. Is that true or false? That's true. This is now session 2 on engine-driven pumps for the hydraulic system of the Airbus A350. Engine-driven pumps, there are 2 per engine, one for each of the hydraulic systems, green and yellow, and they are located or installed on the accessory gearbox of the engine. And we're going to go into a little bit to talking about depressurization, when that occurs, and also the disengaging of the engine-driven pump from the accessory gearbox. All right, so engine-driven pumps, just to introduce a little bit of just the description of it, which is pretty, I mean, there's different kinds of pumps, but anyway, this is a pressure-compensated variable displacement axial piston pump. It is on the accessory gearbox, and it's going to run as long as the engine's running. All right, and what are they there for? They're there to pressurize the hydraulic systems. And if you remember from the Airbus A320, the operating pressure was 3,000 psi. On the A350, however, the operating pressure is 5,000 psi. Okay, so these EDPs, or engine-driven pumps, are providing and supplying the hydraulic power and pressurizing the hydraulic systems to 5,000 psi. Okay, so that gives you an idea where they're located, what they're doing, what their function is. All right, now let's go into a little on the, depressurization of the engine-driven pumps. There's different ways, but first, of course, to depressurize or have it in a depressurized mode, the solenoid valve of the EDP has to be energized, and when it is, then certain things can happen. Okay, so the first thing is there's automatic and manual, and automatically it can be depressurized 3 different ways. Manually, we'll talk about one way. So on the automatically, how it automatically is depressurized is one is going to be done when the fire push button is pulled, because now it's shutting off that valve. Okay, so that will be a trigger for the solenoid valve being energized. And then also the propulsion control system. So you'll have an automatic depressurization by the propulsion control system in case of engine start. And of course, once you have the engines correctly starting, then the EDPs are going to start kicking in again. They're going to be start pressurizing. Automatically also by the fuel quantity and management system. If there's a low level of fuel and also a hydraulic temperature of more than a certain number of degrees. So when you have that combination, there'll be the depressurization of the EDPs. Okay, so those are your 3 ways automatically. Now what about manually? Well, manually, it's going to be by the pump off push button switch. Okay, that's the other way. Okay, and just be aware that, you know, what I said earlier, there are 2 EDPs per engine. Okay, so each EDP is for each of the hydraulic systems. Well, that means that, remember, you have 2 engines, and that means you have 4 EDPs total, and then you also have 2 EDPs per hydraulic system. Okay, 1 from each engine. So what I'm saying is that if you have one of the EDPs that's supplying enough pressure for the system, then there's going to be an automatic depressurization of that other EDP, which is on the opposite engine. Okay, depending. So anyway, that's what it's going to do. And of course, there's the logic here with the EDPs. If it has high demand of some hydraulic consumers, like I talked about earlier, the user systems on board the aircraft that use the hydraulics, for example, your landing gear and flight controls, is received, then the logic is going to be inhibited, and you're going to have both the EDPs in the hydraulic system that are going to be operating. Of course, you're going to have sensors at the manifolds to detect those limits so that it can trigger the operation and pressurization of both the EDPs. All right, so it gives you an idea on the depressurization mode. Now let's kind of go, we're going to talk a little bit about the disengaging of it. So for example, if you needed to remove it from the accessory gearbox, it's actually done manually. So it's a mechanical mechanism that we're talking about. Okay. Of course, this is going to be on the ground. You're going to have to open up the fan cowls to access it. And then you're going to need certain sockets. I don't want to mention which ones because I want to make sure you have it in your head, whatever they tell you at your MRO. Okay, but they are 2 different socket sizes that you're going to use. One is going to be for the disengaging, okay, of the clutch mechanism that holds the EDP to the accessory gearbox, and also can obviously then connects to the torque motion coming from the engine. And also there's another, another tool, another size socket that you use to engage the EDP to the accessory gearbox. Okay, but that's all done there. And you're also going to be looking at, obviously, at the hide page to make sure that the pump's offline or online, depending on what you're doing. So let's just kind of go a little bit through the steps. Remember, this is just for information only. You want to make sure that you do follow your maintenance manual at your MRO. And obviously, we're talking about from Airbus and what they say. So with the disengagement, so let's just say that you needed to get the EDP removed. You're going to need to open up the engine fan cowls and access, that, and you need to use. There's a declutch mechanism there that's going to cause, it to disconnect. But you're going to have to turn using the tool. You're going to turn it counterclockwise until you can see in that visual cutout, the word off. So that's what you're doing there. And of course, once you do that, it's now disengaging its connection from the accessory gearbox, which connects to the engine. So, essentially, there's no connection between the engine and the EDP at that point. This is all mechanical, like I was saying. But again, you're going to be turning counterclockwise, and you're going to be looking for that cutout that says off. And so that's one thing. That's physically, visually, as you're working. But then when you are in the flight deck, you need to bring up the hide page, okay, the system display page for hydraulics, and make sure that the display is showing that the pump is offline. Okay, and the way it's going to show in orange with a DISC, okay, for disconnect. But that's going to be highlighted next to it, and that's going to also be in the color orange. Okay, so all of this is a manual thing. Now, let's say that you needed to re-engage the EDP. You're going to be doing a similar action, but you're going to be using a different socket, different size socket, and you're going to be doing the counterclockwise, but you're going to verify that as you're doing that, the visual cutout is going to say on. And of course, you're going to be checking in the flight deck, bring up the ECAM hydraulic SD page, your system display page, and just make sure that the pump's online, and it'll say that. And then the DISC that you saw earlier should not be displaying on the display. All right, so that gives you some idea on the engine-driven pumps, where they're installed and located, on the accessory gearboxes of the engines, and the depressurization. You know, when does it get triggered for depressurization, and also the disengaging and engaging of the EDPs. We are on to the next session, which is on the auxiliary hydraulic system. And if you look at your handout, there is a question, it's a true and false, and that is there are 3 main hydraulic systems. The answer to that is false, because we only have 2 main hydraulic systems. Those are your green and yellow. And now I'm talking about an auxiliary, not a main one, but an auxiliary hydraulic system. The engine-driven pumps that I mentioned earlier are for the main hydraulic systems, okay, for your green and yellow. Now, when I'm talking about the auxiliary hydraulic system, we'll get into what are called the electric motor pumps, or EDPs. Okay, so auxiliary hydraulic system. We are here when you look at what makes up the auxiliary hydraulic system is that you have an isolation valve, you have a system manifold, you have ground connectors, you have a hydraulic auxiliary pump that's on the yellow ground service panel, and you have these electric motor pumps. So here you have 2 EMPs, electric motor pumps, one for each hydraulic system, and those are installed in the main landing gear bay. And all they're doing is changing electrical energy to hydraulic, right? The electric motor itself is a 230 volt, and the hydraulic pump that is there is supplied with power from the electric motor. Okay. Now, why is the auxiliary hydraulic system here? Why does it exist? Its function is to provide the hydraulic fluid for maintenance, also for the cargo door operations. Okay, that's the yellow system only, and also for brake accumulator refill. Okay. All right, and then auxiliary pump that I mentioned earlier that's installed on the yellow ground service panel. This can be used also to generate hydraulic power for the cargo door operation, and it's done manually. You could do it with the handle or with the power tool at the ground service panel, at your GSP. You also have an isolation valve because what we want to do is isolate the cargo door supply line from the rest of the system. Okay, that way you can just operate the cargo doors or do the brake accumulator refill without employing the entire the full hydraulic system with all the cycles that it goes through. So that's why that's there. Now the manifold, there's a manifold, and the system manifold has pressure sensors. It has a sampling valve. The sampling valve is for hydraulic fluid testing, just to make sure that, or just basically monitoring any contamination that's in that fluid. Also, as part of the system manifold is a high pressure filter assembly. Okay, that type is a no bypass filter, and like I said before, you have several pressure sensors that's going to sense obviously the pressure for the system, and if there's a pressure drop below a certain limit, then it's going to be responsible for sending out an alert.